the the next few questions we are going to solve problems. Now, problem solving using these three equations here. We are going to do problem solving using these three equations. Now, this problem, you read first, then I explain. Problem 2.5, this one. A car traveling.
Oh, I muted. I read already. Sorry.
Ah,
A
yes.
car traveling at a I read already, but I forgot I was muted.
Okay.
Sorry. I forgot I muted. Sorry.
So did you read this one?
I read already. I read already.
Read, read. Okay.
Yeah, that's why I was like
So
waiting. Hey, you didn't respond. Now I realized I muted. Sorry. Yeah.
so we have two vehicle, right?
Yeah.
One is a car. So this is the billboard here. So the car travels, then pass like that. Okay. Oh, there's a policeman hiding behind the billboard. Okay. So as the car passes through, after 1 second, then this policeman start, okay, chase after the car. So there is a difference in time. The car is 1 second ahead of this policeman. Okay, no? It's 1 second ahead.
Mm-hmm.
Okay. So that 1 second, I cancel away. We say they start at zero, right? Start at zero. So I have drawn it here. I've drawn it here, right? I've drawn it here. So you look at this part, right? This part. Okay. So when the t is zero, right? For the car, and also when the t is zero for the policeman. Okay. So we assume that the two of them start at the same time. Okay. So that 1 second ahead not counted lah. I don't count that 1 second.
Okay.
Okay, right. But uh, quietly I calculate that 1 second, how far has the car traveled before the police can react to the car. Okay, so this car is 1 second ahead. Now during that 1 second, right? During that 1 second, because the car is traveling at a constant speed of 24 meter per second, that means during that 1 second, you the distance traveled by the car is 24 times 1. 24 times 1 because it's 24 meter per second and 1 second, so 24 times 1. So this car is actually 20 has traveled 24 meters during that 1 second. The car has traveled 24 meters, so it means that the car is 24 meters ahead of this policeman. So this policeman start his journey, and finally he catches up with the car here. Now when he catch up with the car here, the total distance traveled by the policeman and the total distance traveled by the car, which is addition of these two, right, must be the same. So if they travel the distance same, that means they can overtake the car. Is this okay? Okay or not? Okay, okay. So now I calculate what is the distance traveled by the car. Okay, so the car
Mhm.
distance traveled by the car is 24 times the 1 second, the one
Yeah.
second ahead of the policeman. Then I use 24 times t second. So this t second is the time that is together with the policeman. So the total distance traveled by the car is actually over here, 24 plus 24t. The 24 is before the policeman start, and the 24t is after the policeman has started. Is
Okay.
there is there any lapse in the time?
No, no, no.
Lagging? No lagging. No lagging.
I can hear you perfectly, sir.
Okay, you can hear me. No,
Mm-hmm.
there's no lagging. Okay, right.
No.
So so this is the total distance traveled by the car, the 1 second, and also the time taken later on. Okay, so I add up these two and I put it. I say it is the x of the car. So it's 24 plus 24t. The 24 comes from the 1 second before the policeman start, and the 24t is the distance traveled by the car during the when the policeman has started his catching up with the car. Okay, so now I want to know what is the distance traveled by the policeman. Now the distance traveled by the policeman, we use this formula, x equals
Okay.
to v naught t plus half at square. Why use this formula? Because this is the only formula that has the x, the displacement. Now the other formula that has the displacement, which is this one, involves the final velocity. I don't know the final velocity, so I cannot use the third equation. I can only use the second equation because I know the initial velocity. The policeman start from rest because he is resting behind waiting behind the billboard. Okay, so he start from rest. So I use this formula, v naught, which is 0, plus
Mm-hmm.
half at square. A is 3, it is given here, A is 3 meter per second. So it's 3 meter per second square. And the t square is t square because we don't know what time the policeman will catch up with the car. Don't know, right?
Okay.
But I know this is the, sorry. I know this is the distance traveled by the policeman. And this is the distance traveled by the car. So when they catch up, these two distance must be the same. The x for the car and the x for the policeman must be the same. So I equate this x for the policeman with the x for the car. Equate them, link them together. So when I equate them, I get a quadratic equation. Do you know how to solve a quadratic equation? Yeah. Quadratic equation, you over here the 24 and 24, but there's a 3 here, there's a 3 there, you divide by 3, multiply by 2, divide by 3, this will be 8 and 8, multiply by 2 will be 16 and 16. So I have a quadratic equation, t square minus 16t minus 16 equals to 0. So this is the quadratic equation. Now the formula for solving quadratic equation is this: minus b plus or minus square root of b square minus 4ac divided by 2a. Have you come across this formula before? Solving quadratic equation? Yes, sir. You have learned before. Oh, okay. So I substitute the A, B, and C inside. A is 1, B is negative 16, and C is also negative 16. You substitute everything inside, then use your calculator, you calculate. So the time the policeman catches up with the car is 16.9 seconds, or negative 0.94. Of course, the time cannot be negative. So we reject this and you accept 16.9 seconds as the answer. So after 16.9 seconds, the two of them will have traveled the same distance. So if they've traveled the same distance, that means the policeman can catch up with the car. Any question?
No, sir. No.
No. So finally, the last part. How fast is the trooper going at that time? We want to know the final velocity. When he catches up with the car, what is the final velocity? So we use this equation. V equals to V naught plus AT. V naught, the starting velocity of the policeman is 0. And the final velocity we can calculate. Acceleration is 3. The time taken we use from here, 16.9. And when you multiply together, answer is 50.7 meter per second. 50.7 meter per second. That is his velocity. Now, they want to know the graphical solution correspond to the finding the intersection of the two types of curve in the tx plane, or this tx means time versus, let me check, it is time versus position, time versus position. Where is it? Policeman, not this one. Where is it? Yeah, this is the one. 3. How long does the trooper, how fast is going at that time? The second question, yeah. Tx plane, right? Now Tx plane means this one. Tx plane means this one. The graph of displacement, the position versus time. Position versus time. Now, for the car, they start at 24. The displacement is 24. Okay, 24. At this starting position here, okay, the car has already started 1 second ahead. That means his displacement is already 24 meters. So it is 24 meters. And because it's traveling with a constant velocity, the displacement time graph will be a straight line. So start from 24, the car travel at a straight line. With a constant velocity means it's a straight line. Now for the policeman, the displacement time graph is actually a curve. It's actually a curve, like this. Because the policeman is accelerating, the velocity is increasing all the time. So it has to be a curve. Why? Because along this curve there, the tangent, the slope of the tangent is increasing. The slope of the tangent is increasing shows that the velocity is increasing. The velocity is increasing means it is accelerating. So curve like this shows acceleration. So the policeman must be traveling in the curve, right? So it has acceleration. But what time the two of them meet? They will meet after 16.9 seconds. So at this point, when the path cross, the policeman and the car, they cross path, and that time is 16.9 seconds. That's why they intersect at this point. The two lines intersect at this point. Now, when they intersect, it means that the total distance traveled is the same, right? 16.9. Any question? No question, huh? I tell you what. Oh, never mind.